So today we're going to talk about the norm. So a definition for the norm is that, so for example, the vector x, which has the components x1, x2, x3, all the way to xn, the norm of this would be x1 squared plus x2 squared plus x3 squared and so on until you get to the end plus xn squared. This is equal to the distance from the origin to the point x1, x2, x3, etc. The magnitude of the distance of the vector is the norm. Distance can also be described using a norm. So if you have point 1, which is x1, x2 to xn, and point 2, y1, y2, yn, then the norm of the two is, the distance rather, is the norm of the two. So you just subtract the x components from the y and take the norm. Some properties of the norm. So first, the norm is always positive. We know this because it involves the square root and addition. Second, if the norm is 0, then the vector is a 0 vector, so a point. Third, the norm can be multiplied by a constant, so scalar multiplication. The norm, it's just like any other vector. It can be multiplied by a constant, that sort of thing. Also, if you have the addition of two vectors, and the norm of that would be less than the addition of the norms of the two vectors. So you can imagine this as the hypotenuse of a triangle would be the norm of the two vectors added, and then the legs would be the norms individually added. So we know that the hypotenuse is always less than or equal to the sum of the legs of the triangle in terms of length. So a unit vector is any vector with a norm of 1. So the unit vector of a particular vector is the vector divided by the norm. Standard unit vectors are e1, e2, all the way to en, depending on the space that you're working in. And it's simply as shown. E1 would be 1, 0, 0, 0 until however many dimensions there are in the space. Same thing with E2, except the 1, of course, would be in the second position, and En, the 1 would be in the last position. Any vectors in real space can be represented by a combination of the standard unit vectors. So for the example today, we're just going to find the norm of the vector x, which is 2, 4, 5. And then there's also an extra example, which you can try on your own before looking at the solution, which will be posted below. So first, we'll find the norm of x equals 2, 4, 5. So the norm, this should be a vector, sorry. So the norm of this is simply as we saw, just all of the components squared and added, and then take the square root. So 2 squared is 4, 4 squared is 16, and 5 squared is 25. And this would simply be the square root of 45 is the norm. So that is the distance of the vector x, essentially. All right, thank you for watching the video. Thank you to Loom and to Google Keep, and of course to my professors. I hope this helped. We'll see you again next week.